The switch is a fundamental building block for all electrical devices. Of the many switch types, Hollywood loves the knife switch.
Go!
The variations are endless, all with the same goal: to switch or route electricity. Let's consider several switch concepts. The first type is primitive, pushing two wires together or apart. It's the first electrical switch. The manual switch is much safer and very common. There are varieties galore. Here are just a few commonly used types. Another class is switches that operate by a force, typically not by muscle movement. The pressure switch toggles based on air or gas pressure force, PSI. Mercury moves inside a glass container and connects two terminals based on position. The force in this case is gravity. A limit switch is operated by some external force, such as a door opening. Thermostat switch operates based on the thermal expansion of dissimilar metals. The magnetic switch opens or closes, controlled by a magnetic force. Lastly, the MEMS switch. This switch closes based on an applied electrostatic force. It is very small, on the order of 50 microns. Next, let's consider two switch types that rely on movement. The first one is called an acceleration or inertia switch. It operates when a force moves a mass and this causes two contacts to bridge. It may be used to detect a vehicle crash, for example. The second device is called a centrifugal switch. The central part of the mechanism rotates. The two spring-loaded masses extend outward as a function of speed. The weights bend an arm that opens and closes switch contacts, A and B. In this video, the switch closes immediately on motor startup. It opens as the motor slows down at some target rate. Notice the two weights. This mechanism can be used to help maintain a constant shaft rotation rate. New switch ideas are common and inventors never seem to sleep. Another approach relies on electromechanical techniques. There are a wide variety of methods. The relay is a prime example. All relays have at least one electromagnet. This is a coil of wire around a soft piece of iron. When current flows through the coil, the electromagnet attracts a flexible metal arm and this opens or closes electrical contacts. When the coil current ceases, the contacts take their home position. Relays may have many contact types. The coil is activated by an external switch. Immense electromagnets and even motors may control some high-powered switches. Finally, there is a class of semiconductor-based switches. A transistor, and related devices, can switch current. The analogy of a faucet helps to understand the transistor as a switch. The faucet has input and output ports and a valve to control the flow of water. Let's call the in and out ports the collector and the emitter. The control valve function is called the base. Here is a transistor connected to a lamp. A current flow into the base terminal controls the flow of electricity between the collector and the emitter. With no base current, the transistor acts like a switch that is off. With sufficient base current, the transistor turns fully on and the lamp is on. With no base current, the transistor shuts off. So, the transistor joins the list of devices that can act as a switch. Switches are essential for math and logic too. Here are 3 switches. Let's use them to implement this simple Boolean statement, A and B, or C. If true, a lamp goes on. Here is a circuit diagram implementing the statement. The top portion has the A and B switches. The bottom switch C is part of the OR function. Toggling switch A does not light the lamp because B is off. Now, if B is on, the light is on. Switch C alone lights the light. So, if A and B are on, or C is on, the lamp is lit. This demonstrates the power of the switch to perform logical operations. This idea can be expanded to implement math. The first 1-bit digital adder was built by George Stibitz in 1937. He was a mathematician at Bell Labs. It only uses 2 relays with 2 hand-operated input switches. 2 lamps indicate the output values. It was the first electromechanical computer built in America. Now imagine thousands of relays wired together to compute. Here is the Zeus Z3, invented by Konrad Zuse. It's the world's first electromechanical computer, with 2,500 relays. It proved that switches can be configured to compute and solve logical problems of any magnitude.
From high-voltage switching to the humble toggle switch, from the internet and computing to artificial intelligence, the electrical switch performs a critical role in modern life. Importantly, switches were also essential for building electromechanical telephone systems. Part 2 of this video explores how switches were used to link millions of users across the world's telephone networks.